Hey students, this is lesson 5.5. In this lesson, we're going to learn how to use indirect reasoning to write proofs. Go ahead and do the review and I'll check back with you. All right, we're going to learn how to write indirect proofs. So, and actually, if you look at a problem like this, right here, and these game boards are in your packet, but the idea that you use to eliminate possibilities and choose the only one possible is indirect proof. So, like in this first one, you might say, well, I know that this one is either a 3 or a 4, and we know it's not a 4 because but we know this can't be a 4 because we already have a 4 in this line. So, so we know that it has to be a 3. And then this is a 4. And so on. And that kind of reasoning is indirect reasoning, and that's what we're going to use for this proof. Another thing I'd like to mention is that, remember when we had conditionals? And so if our original conditional is if P then Q, we found that the contrapositive of that conditional, which if not Q, then not P, if that's true, then so is this. And that's kind of the idea that we'll be using for indirect reasoning. All right, so here's how you write an indirect proof. Step 1, you state as temporary assumption the opposite or negation of what you want to prove. That's the not Q part. And show that this temporary assumption leads to a contradiction. So that contradiction is we find out that our not P is true, and then we conclude that since not Q then not P, then if P then Q must be true. So let's take small steps here. The first thing we want to do is learn how to state the temporary assumption. So let's look at these two examples, and I'll number them 1 and 2. And so the temporary assumption is the negation of what you're trying to prove. All right, so look at what you're proving and just do the negation of that. So in this one, we're trying to prove this, that there are at least 16 right-handed students. So if I use R for right-handed, then that means R is greater than or equal to 16. So the negation of that is that we are going to assume that we have less than 16 right-handed students. And the way we show that is just R is less than 16. Or if we were to write it out, we would write there are less than 16 right-handed students. And in the second one, we're trying to prove that n is divisible by 2. So our assumption would be, what we would want to assume if we're doing an indirect proof, is assume that n is not divisible by 2. And we would just write that out. N is not divisible by 2. All right, you try that. All right, problem 2. You have to be able to identify a contradiction. When you get that contradiction, then you essentially, that you are proving what you want to prove. So you have to be able to identify that. So look at this situation. Which two statements contradict each other? The first one says triangle URT is acute. That would mean that all angles are less than 90 degrees. Number 2 says that triangle URT is scalene. That would mean that all sides have different lengths. And the third one is triangle URT is obtuse. That means one angle is greater than 90 degrees. So we have to figure out which of those statements are contradicting each other. So the two that contradict each other are that triangle URT is acute, because that would mean all angles have to be less than 90 degrees. And this one, triangle URT is obtuse, because that would say that one angle is greater than 90. So those two statements contradict each other. Go ahead and practice that. All right, so let's put it all together and write an indirect proof. So the first step in writing an indirect proof is write down your temporary assumption. So for this one, we are going to assume that y is equal to 7. So it's the negation of what we are trying to prove. And for a reason, let's just write that that's our temporary assumption. Okay, and then once we have that, we can go ahead and write what we have for the given, part of the given anyway. And then we will substitute, and we get this. And we can divide both sides by 10, or by 5, and we get x plus 7 equals 10. Make this division property of equality. And then subtracting 7 from both sides, we get x equals 3. And right now, I'm going to write the other thing that I'm given, and that's x is not equal to 3. And that is our given. And so I'm now going to say that y, since I get a contradiction by assuming the negation of what I was trying to prove, I'm going to say that y is not equal to 7, which is what I'm trying to prove. And we're just going to say proof by contradiction. All right, you try one of those. All right, that's the lesson for the day. Go ahead and do the lesson check, and we'll talk about it next time we meet in class.